Thank you for coming to this presentation. Here's something about me first. My name is Dimitar and I'm coming from Bulgaria, and I'm a managing director of a small software consulting company back in Bulgaria. And I'm also a accredited Kanban trainer from LKU. And also something interesting and important for me is that I published some books in Bulgarian language. So we published in Bulgarian language the Blue Book, the Kanban book, and also we published 2 books by W. Edwards Deming and 4 books by Eli Goldratt. So that's all about me. This talk will be about probabilistically forecasting project sizes, and this is a topic which I face every day, not every day, but on a very regular basis when we have to make quotes for prospective projects and portfolio decisions. So here is the definition that I would like you to stick with, what we'll be talking about. So when we have to estimate the time and the budget needed to deliver a new software product, we need to know what and how much software we need to deliver. We need to be able to quantify this how much. So this quantification is referred to as sizing. And I put on this slide quite a lot of words for you to hopefully later on use. So what actually sizing means, and I read it through. So project sizing is different from delivery time estimation. Sizing estimates the probable size of a piece of software, while delivery time estimation forecasts the time needed to build it. The relationship between the size and the time needed for delivery is referred to as productivity. So we are talking sizing here. When we talk about sizing, first we have to decide what units of measure shall we use. So in the past, in the deep past, and I believe Barry Boehm is here, so back then they measured the size of a software product in source lines of code. And later on, function point analysis was introduced, and they measure the size from a user's perspective. And function point analysis even made it to be codified into several ISO standards. So it's a standard way today, especially with DoD project, it is a standard. In agile projects, most of the teams use sizing techniques, and they measure user stories. So the 2 most popular sizing techniques are the relative sizing using t-shirt sizes, small, medium, large, and so on, and story points. Both the advantage of using relative sizing, which is t-shirt sizing, is that for people it is really very much like easy to start. The disadvantage is that t-shirt sizes are not additive. We cannot say that the project is 10 smalls, 2 mediums, and 5 larges. Like, we cannot quantify, that's the thing. We can just compare relative sizes. Story points, we can add them, and we can quantify using story points. So the story points, according to Mike Cohn, and that's my source for this, he says that story points are about effort. It means that story points measure the size in terms of effort. Also, effort is defined as person man-days or man-hours. But as we established in the beginning, software sizing is different from software effort estimation. Because again, the size measures the size, and the effort estimation measures the effort needed. In Kanban, project sizing is done by simple counting of things. Usually it is number of stories, number of features, number of use cases. I'm not sure if Eric is in the room, but like in his book, which was on sale outside, they measure the size of a project in the number of tasks. In general, any type of work item that is suitable for the development organization can be counted, and we can count, by counting, we can actually size a project in Kanban. To plan deliveries, we have to actually have like big and small work items, and usually the bigger items are features or epics, and we break them into user stories. If we need to size a significantly large project this way, we have to analyze each and every user story. And this could easily happen to be a waste, because requirements change, something will come up new, something will be dropped, priorities change. So this practice is hard to follow. It's pure waste, people know it, and that's why most of the time they don't want to size initially, like upfront. And this is an example of a project sizing in tasks. Let's say we are sizing in the number of tasks. And let's say we have identified 16 epics, and those 16 epics, they contain 102 user stories. And then we analyze and sized in the number of tasks each and every user story, and the end result is 396 tasks for our project, which is okay if we have like time to spend, and time is money, and the team most probably will defer doing things like that. So here is the question that I stumbled, everybody faces, I believe, in our business on a regular basis. So how can we estimate the total number of stories or tasks for a project without prior identification, analysis, and sizing of every single user story? And end of last year, when I decided to find some analogy in the world outside, and I thought there must be a way for doing this more scientifically. And I just had a kind of idea to look into how they do it in horticulture, because I thought nobody will going to count the number of fruit on a tree, especially if it's a big garden. It's terrible. Nobody will do it. But there are forecasts for how the produce, how big will be, and everything else. And it turned out, actually, I found by chance that there is such a technique. And it is called randomized branch sampling. It was proposed by an American statistician called Jessen back in the 1955. So it's in use since then in horticulture, in forestry, in these domains. So the technique, it's a multi-stage unequal probability sampling. That's enough from a statistical point of view. And it's a technique designed to efficiently estimate the total number of fruit found in the canopy of a tree, only having to count the fruit on select branches, which is really useful for the horticulture people, and as we see, for us. So I thought how to use this technique, and it's quite natural, actually, to map a tree to a product backlog, and the way we break the work down into smaller chunks. And it's quite easy to represent a product backlog as a branching system. And here it's a fictitious product backlog, and we see that in product backlog we have three epics, A, B, and C. Epic A has two user stories, 1 and 2. Epic B another two user stories. and epic-C will have 3 other user stories, 5, 6, and 7. So that's common in our business, and most of the teams do it anyway, in some form or another. The technique, that's the only statistical part of the whole presentation. There will be no talk, no words like distributions or anything like that. So that's just for you to, if anybody is interested. So the technique is based on this, on the Horowitz-Thompson estimator, which produces unbiased estimates. So that should be enough for using the technique at all. It's just for you to know. So visually, the technique can be presented that here, at least I tried. So the biggest rectangle at the bottom, that's the product backlog. And we have epics and user stories. And the size of the user story is expanded by this technique by dividing the size of its selection probabilities, and we actually try to find the size of the product backlog. So that should be enough for from a mathematical perspective. And then I had this internal argument with myself, which is okay. Like, is this technique applicable at all to software development? So the question here is a real question, because the number of fruit found in the canopy of a tree has inherent abstracted from its interpretation objective value. It means that if we count the fruit several times, we should come with the same number plus or minus some counting error. So that's okay. It is because the fruit is already there. We are counting something that is there. The size of a software project has no objective value. It's intangible, and we do it upfront, right, before any additional information coming from the customers. So the size is a proxy for all the capabilities, features and functions that the final product is required to have when delivered to the customer. But we know that the requirements change, and actually it's good to change, and we learn as we work on the project, and we discover new requirements. So if we apply this technique to a branching system like the product backlog, actually we are sampling from something that is non-existent, literally. So that was my question. And my assumption when I tried this technique was that, and that's again some words for you, the assumption behind using RBS for software development is that the project size, in general meaning size, depends on the context, the customer, the people developing the product, and the methodology that these people will use for managing the requirements, breaking down the requirements into stories, and analyzing them. So the assumption is that there is a methodology for doing this, and that the important thing is not the type of the methodology, but that any methodology be used explicitly and consistently, and then the methodology must be cohesive and self-consistent, right? That's the assumption. But again, it's just assumption, right? And this is a quote from the Kanban book, from the Blue Book, page 221, from David Anderson. And he has there that the method of analysis used to break down requirements, let's say the methodology that I'm referring to, for development, it has its own degree of variability, right? So it is kind of a profound statement, I would say, from the standpoint of usage RBS, as you will see later on. So what I did, I teamed up with Ajay Reddy, who is in the room, and the Scrum Do team to see if RBS is applicable. And they have tens of thousands of customers, and their customers have projects, so lots of data. And Ajay and his team was kind enough to look into the huge amount of projects they have and just to pick a handful of projects for me to test the assumptions. So the projects that they picked is they comply to several criteria, which is first of all, the project should have a branching structure, which is epic story task breakdowns, successful release history, stable systems or teams. They have active Scrum Do coach or Scrum Master. They are commercial projects. And they have a minimum size of 12 epics or features. And they picked up for 13 projects, and we ran the simulation on this. So the simulation, these are the results. The simulation itself and the data, it is available on the Scrum Do website, on the blog, I believe. Yeah. So it is in the form of Google spreadsheet there, so you can go and download it and see how it's actually calculated. It's really just multiplying and dividing numbers, nothing spectacular. So this is the result when what we did actually, we took the historical data and we ran the simulation on the data and we compared the results of the simulation from the actuals. And on the horizontal dimension is the estimated with RBS values in terms of in size of stories. And on the vertical axis, we have the actuals. And it is a Kanban conference, and I have this slide especially for Jasper to show that actually it works with stories, and later on with story points. So this is what would like the results between the correlation between the estimated and the actuals. And you can see that the correlation coefficient is really high. It's a very strong correlation. It's almost unbelievable. Absolutely unbelievable. Like, it's visually, the correlation is there, but when we calculate the linear correlation, it's almost unbelievable. So here is using story points because we have data for story points. So here the correlation is a bit weaker, but again, very, very strong. It's almost a functional relation. And then we did the same for the number of tasks per user stories that those teams did. So here the correlation is the weakest, again, very strong, but the weakest correlation. Anyway, the data show that actually our assumption that there is something people do when they manage requirements and break them down and analyze them, they use a methodology. So if a methodology is used, like as you remember, like the stables teams and everything, RBS can be applied to software development, to sample from the future, actually. And this is really, really nice. You can find, first of all, the data on the Scrum Do website, and also I wrote the article for infoq.com, and there is lots of explanation, actually technicalities, if you are interested. And also, the material can be found in Ajay's new book, which is called Scrumban Revolution, which will be out in July, right? But it's really simple math. So these are the results. And here are the conclusions from the results. And I read it through because it's important. So the conclusions is that during project execution, all project teams, and these are different teams. They don't belong to the same company or anything like that, right? They are different. selected at random. That's very important. They're selected at random. So during project execution, all project teams consistently applied a methodology. We don't know what. For slicing the requirements into user stories and tasks. And also it shows that during project execution, the teams maturely manage the emergent and high change risk requirements, right? Because there were new requirements coming while they learned. So they somehow they managed to keep everything consistent. Like their results, the way they did this slicing was really consistent and shows maturity. And very important conclusion is actually that execution is more important than the planning. That's maybe it's not comes directly from the data, but it shows that actually how we do the work is much more important than how we plan for it. And where can we apply RBS? So I showed results when we can estimate the total number of user stories in a project, for instance. We can estimate the total number of tasks in the project. We can estimate the total number of behavior-driven development scenarios or acceptance tests in a project. That's what I use, right? But very important application is that we can assess the maturity of teams in their usage of a sizing methodology, which I would like to shed more light on this. So assume you have data for your teams, let's say 12, 10 projects. Using RBS, you can judge if the teams actually consistently applied any kind of technique for managing the requirements, right? The technique they are supposed to be used, you can tell, are they using it consistently? Or just like figuring like numbers, random numbers and so. You can also test if you have a team being trained in a particular sizing methodology, and by methodology, it could be planning poker, it could be product sashimi, it could be feature-driven development, anything, right? That's what I say methodology, right? So if you have a team that is trained in applying, let's say, planning poker, you can after several iterations or projects, you can actually see if they apply consistently what they learned, which is very useful. So some example how actually this is being done. So here we will apply it for estimating the total number of user stories in a project. Again, the idea. So we have a branching structure, which is product, epics, user stories. That's our structure. And it's the analogy. Like we map the product to the trunk and the epics to some branches. In user stories, let's say the user stories are shoots where the fruits are. Right? That's the mapping. And again, something like as a documentation for you. So product is the trunk, epic is the branch, user story is the terminal shoot. So here's the formula. There is no need for you like to remember it or anything. It's really simple. We just need the number of user stories in a sample epic and the number of epics, the total number of epics into the project. Again, it is available as an article on infoq.com, so you'll find it there. And then we do several samples, and we average the results, and that's the formula for averaging the results. And we actually come out with the number of user stories for the project. So here is the algorithm. Again, I'll go quickly through this because it's not a math like presentation. So first step, what we have to do. We have to divide the project scope into epics. Second step, we randomly sample one of the epics. And randomly is the critical word here. We have to sample at random. We sample one of the epics. Let's say we have 12 or 20 or 100, we sample one. And then we break down this particular epic, only this epic, into user stories. And we write down the number of user stories. Then using the formula, the estimator, Actually, we make one estimate of the number of stories in the project. And then we get back and repeat point 2, 3, 4, 5 again. So we are doing this sampling between 7 and 12 times. With the Scrum Do data, I did it for only 7 times. And then we average out the result. And here is a calculation, like one of the projects from the Scrum Do data. The project had 29 epics and a total of 529 user stories. So that's the historical data. So assume that we had to size this particular project in the normal way, which is actually to analyze all user stories, right? Or all epics, to break down all the epics into user stories. So it's a bit of a work. So here is the calculation again, just for you to grasp it, like just, it needs some practice with Excel, but anyway. So in the left-hand column, we have the random epic selector. So this is the random number that will return us one epic out of 29. So in the second column is the number of epic that actually was randomly selected. In this case, it is like the first row, it is epic number 22. And then we break down the epic into user stories, and it turns out that this epic has 19 user stories from like using our methodology for breaking things down. Right? And the epic selection probability is calculated using the formula I showed before. And our first estimate is 551 user stories in the project. And then the second row is the next sample, next estimate. Again, we generate a random number. Based on this random number, we pick one epic. We split the epic down into user stories. And using the formula, we come up with, this time, 464 user stories. So we do this 7 times, and we average out these numbers. It's like in the table where it says estimated project size. So the estimated project size with only 7 samples is 497 user stories. The historical, the actuals, it was 529. So it's not precise, but with only 7 epics analyzed, we ended up very close to the real thing, right? So here, David probably is not in the room, but this is from Lean Kanban Central Europe back in 2011. And this is David Anderson showing how we can probabilistically plan a project, which is right now, I believe, part of the ESP training curriculum. And at minute 42, around there, so he presented how to estimate the number of work items. In this case, it was user stories for a project. So the algorithm, I just put it again as a document, but it is exactly the same. He samples at random 7 epics, 7 or 11, and then we'll analyze them into work items and then average out the result. And that's his formula, following the algorithm. And actually, the formula is the same formula that we just used for estimating the number of user stories in a project using RBS. So what David presented back then is mathematically sound, and it is one of the applications of RBS. Back then, most probably, he wasn't aware of the math, but anyway, so the approach that he advertised so many years actually is mathematically sound. So here again, another example for estimating total number of tasks in a project. Again, using Scrum Do data. So we estimate we break down or analyze a story and establish the number of tasks, which probably in this case are technical tasks to be done so that the story to be delivered. That's what tasks mean. People use it. Right? And here is the branching when we use this unit of measure. Again, we have a project. We have on the second layer, we have our epics. The third layer, we have our stories. And then on the fourth layer are the tasks. So every story is analyzed, and we establish the number of tasks needed for the story to be considered done. So again, it's a branching structure, a different branching structure, but again, branching structure. And here again is the mapping. Product is the trunk, epics are the branches, and terminal shoots in this case are the tasks, which is the same structure, well, quite a bit larger, but the same branching structure. The formula is a bit different. There is no need for you like to even think how to remember the formula. It is out there on infoq.com. And again, we need just the number of epics. That's mandatory all the time. Every time we need the number of epics. And then we sample at random some stories, and then we estimate, we find the average estimate. So here again is the algorithm. So it's a very similar algorithm. So on first step, we divide the project scope into epics. And then we randomly sample one of the epics. And then we analyze how many stories are in only this epic. And then we randomly sample one of the stories that we just analyzed. And then we establish the task for that particular story. Using the formula, we estimate the total number of tasks for the project. And then we go back to step number 2, do all the steps through 6, 7, between 7 and 11 times, depends how lazy we are. And then we average the results. And again, a calculation using Scrum Do data. So that particular project had 15 epics, 720 user stories, and a total of 5,000, too many tasks, right? A lot of tasks. Yeah, so it's a huge effort. If somebody has to establish this upfront before before the start of the project, it's impossible, right? It's absolutely impossible. It's so much work. And here, like a bit more numbers, but you can, hopefully you can see the pattern, right? On the left-hand column, again, we have the random number that will return us one of the epics. In the first row, based on the randomly generated number, we got epic number 14. Then in this particular epic, we analyzed, or actually the actual people doing it back then analyzed it into 42 user stories. And then we generated a random number to pick only one of those 42 user stories. And then we analyzed only this user story, and they established that this particular story had 12 tasks. And then using the formula, first estimate of the total number of tasks for this project was 7,500. So we do it the same. The second row, we generate another new random number. This time the sampled epic is number 12 based on the random number. And then we break the epic into 51 user stories. Then we randomly pick one of these user stories, and we analyzed it, and we found that it was 8 tasks for these stories. And using the formula, the estimated total number of tasks is 6,000 and something, right? So you see the number of 7 times we did the same. What is really important, you can see that the last line, actually, in the column which says task for the selected story, it says 0. I don't know why. That's historical data from a team. I really don't know who they are. But that's the data they generated using Scrum Do. Even with 0, right? 0 means 0, right? So this particular estimate says the project has 0 length. So even with this quite unusual number of tasks for a story, so the estimate is 5,023. So just to put it in perspective, the real thing was 5,500 and something. So it is 10%, yeah, 10% difference, right? But we did it maybe in a matter of like half an hour or so. We sized the project into 5,000 tasks. And again, so this, again, the technique for estimating the number of BDD scenarios, scenario in behavior-driven development means acceptance test in general. Like, hopefully there are people who know, like, who is using BDD in the audience? Yeah, so, and I size my project in the number of acceptance tests. That's my preference. So we can apply RBS into using this model. And again, you have a product, then we have an epics on the second level, third level user stories. On the fourth level, this time we have scenarios. And again, we have the mapping, the branching structure. Product is the trunk. Epics are the branches, and the terminal shoots in this case are the scenarios, the number of scenarios. So here is what the scenario is. Again, the mapping, product is the trunk, epic is the branch, user story is the terminal shoot, and the number of scenarios per user story are the number of root on the shoot. So that's the mapping, just to put it in perspective. The formula is a bit different, right? But almost actually the same. This time we are using number of scenarios, and this is how we actually will average the estimates. And the algorithm is absolutely the same. Like again, we start from the project backlog. We break the project backlog down into epics. Then we randomly sample one of the epics. Then we analyze how many stories are in the sample epics. And I read this for you, so hopefully you'll see the pattern, right? It is clear, but I spent lots of time, so for me it's much easier. And then we randomly sample one of those stories. And then we establish the number of scenarios for these particular stories. Using the formula, we estimate the total number of scenarios for the project. We get back and run steps 2 through 6 between 7 and 11 times. And then we average the results. So the conclusion. So RBS is a forecasting technique for sizing software projects without prior identification, analysis, and sizing of every single user storage. RBS can be applied with any unit of measure that is being used these days in our domain, software development. So what we proved that by running RBS on past data from actual projects, we found that RBS would have estimated the same size without all the usual effort. And the third conclusion is RBS helps us to reduce uncertainty regarding how much software needs to be developed when we have to make portfolio-related decisions, provide quotations on prospect projects, etc., etc. So from this perspective, it is really useful. And actually, that was it. I ran quite fast through the slides to allow time for questions, right? Hopefully, there will be questions. If we can get back to a particular slide if needed. So questions, yes. The mic, yeah. Please.
So you had mentioned that you randomly select epics to start off the estimation. Do you ever, or have you ever, or would you recommend picking epics that you knew were going to be hit first so that you can immediately start executing on those epics and use them for estimation?
So the question is, can we pick epics, like when we use RBS for sizing, can we pick the epics that we would like to start first when we start executing the project? And the answer is no. Why? It's called randomized branch sampling, and randomized is the most important word of the three, right? All this, when I say randomly sampled one story or epic, it must be at random. It must be at random. Okay? Next question.
Hi there. Do you have any real life examples of what you've done with this information once you've got it? If you have like, you've run the RBS formula, you've got 5,000 user stories now, you have this figure. What have you then done with that number to convert that into some kind of currency or decision? Do you have any real life examples that you can share with us?
So the question, let me see if I got it correctly. So the question is, do I use RBS for making decisions, or?
Do you have any real life examples of
So I
how
showed,
you've...
we showed real life examples, right? Again, just to get back. So for instance, here is this is historical data from 13 projects picked at random from the thousands projects they have at Scrum-Do. And we picked them at random because if I show you my data, it will be my data, right? So it's not statistics. So this data is real data. People did it last year. They are quite fresh, I believe, I'm not sure. But this is real data. It's 13 different teams from different companies doing we don't know what, right? So the assumption here is that actually it is randomly sampled historical data. I really don't know what it is, where it comes, and what. So to answer your question, I do use it on a regular basis, but this is my data. I mean, I'm really biased, and it is my data will not be, well, at least will not be as sound as somebody else's. Yeah. Hopefully I answered your question.
Yeah, I was wondering, now you have this figure, so you have, for one project, you have 2,000 user story points. What have you used that information for next? How do you then apply that information to your next decision?
Okay, so you say, okay, I got it, sorry. Yeah, first time so the question is how can use it for future predictions, right? The thing is that I don't use it, and I don't encourage you to use it for future predictions. What is here is actually showing if the technique, this slicing and analyzing technique had been applied consistently. But for every new project, what I do is actually I run the algorithms that I showed from scratch. So my assumption is that I mean I don't let's say if let's say I'm working with Jesper, and actually we have a project that we think will be, let's say, 1,000 story points, right? But this is not to show this. Like, this is the correlation between the estimates and the actual. So what you can do is when you run, let's say you run RBS, and you go to the customer and provide the quote. Let's say our project is 2,000 user stories, and we have some data that shows that we will deliver in 2 months, right? Our team, say. And then after 2 months, when you are ready and you know the real number of story points that actually came up, you can compare the actuals with the estimated. That's how it should be done. First of all, to see if actually the technique RBS works at all. And then to see if during the project, your team consistently applied the technique they use for analysis and splitting down stories, right? Because if they don't, based on this statistic that we have, there will be a very weak correlation between your estimate and actuals, which means that people could have, say, applying story points, assigning story points at random, right, without any kind of analysis and stuff. So it's better always to compare the estimates with the actuals all the time. Yeah. Other questions? Yes.
Well, actually, it seems that the assumption is that no new epics will arrive while you're doing the project. Do you ever, I think in terms of actually the releasing to the market, do you track the history of added scope in terms, and I guess from this perspective it can only be added epics so that you can involve that in the final calculation?
Of course, here it's not assumption again. This is a diagram that actually shows that RBS can forecast intangible things, right? But to answer your question, it's a real situation. Let's say, and it's quite common for me as well. So we have a project when we size it, let's say, in 2,000 scenarios, acceptance tests, and of course, as they call, like, not that the scope creeps, but understanding grows, and it's getting bigger and bigger. And here is the question: what should we do, right? What should we do? We have 2,000 initial estimate, and we see that actually it's growing. And there are two approaches, and I use the second one. So first approach is actually when you have something like new requirement, let's say new epic, a whole new epic. You just erase your old data, estimated data, and you run the estimates again. So that's the first approach. The second approach is a bit easier. So let's say I have, let's say, 20 epics and 2,000 acceptance tests, and I have one new epic. Depending which is faster, right? Maybe could be faster, in my practice faster, to analyze this epic alone, right? From the whole epic. I break it down into user stories, then in acceptance tests, and then just add the new value, the new numbers, like the new part of the scope to the estimate. In this case, the estimate grows, not linear, but it's like it grows a bit, right? So we have the estimate as our baseline, and on top of that, we add everything new, right? Hopefully, there will be no 10 or 20 new epics added. So did I answer your question?
Yeah, it's fine. And
again, just to say, it is only for planning, so don't overestimate this technique. As I said, execution is more important than planning. This is only for planning, and this is only for making portfolio decisions, quotes on projects, etc. This level of planning, we should not expect that if the estimate says 5,000 user stories, there must be eventually 5,000. There will not be 5,000, right? Definitely. But what it does, it helps us to make decisions faster. If I have, let's say, 4 projects in my portfolio, and I have a new request, and I have to make a decision, should I accept this work or not, right? And I have to do it fast most of the time. I don't have time to analyze the whole project and to assign a team for this, right? It's not economical. Using this technique, I can see, this project I can fit, right? Or I cannot fit. You see? So don't overestimate this. It's only for planning. Execution is more important, much more important than planning. Okay?
Okay, and just quickly, do you have when you've got history, so you're doing similar types of user stories again you've done before, then it's quite easy to see how you would turn this into a cost or a budget or an effort.
Yes.
But
yes.
What if it's a new platform or a new team you just got together? What do you do then to try to come up with, okay, so we've got 5,000 items, but what is going to be the average cost per item when pulling this through the team?
So if I understood the question, it is when we have new work items, new scope, or
no,
we have
a project where it's not necessarily easy to match these items that you're now going to complete to
It's
previous
not,
items
yeah,
completed?
okay.
And
So the
what is
question
the
is,
effort that involved?
yeah, okay, so yes, it's not about matching. Yeah? See, those 13 teams, we don't know the technology they used. We don't know, was it new technology for them or they use it for a decade, right? We really don't know. What we can say definitely is that they applied consistently a technique or method for analyzing the requirements. That we can definitely say. They were stable teams, mature, stable teams. Okay? So our, yeah, 15 minutes for questions. It's our time is up.
But I'm still guessing that it's pretty important to you when you're making that decision whether it's going to take the team 5 months per user story or it's going to take them half an hour per user story. That must somehow.
It is, yeah. Okay.
And so if that's not clear, then
Yeah.
the decision must lack some information.
Okay.
Doing based on the numbers.
So to answer your question, and finally, so this is one input to the way to my decision making, right? I may have other inputs like risk or my like policy-based decisions. So this is one of the inputs that I can use quite and I can calculate quite fast. So thank you very much. If anybody questions, I will answer. Thank you very much.